In this video, we want to work on important ideas of SMC for 2022, 2021, 2020, 2019, and 2018. Important ideas. We have 24 ideas. As you can see, we will consider them. And also, I will leave 8 homeworks for solving these problems. We will solve some problem from here, SMC 2022. We will solve some problems from SMC 2021 here, and we will solve some problems from SMC 2020. As you can see, problem 25, 25, and work on the ideas. 23 ideas in function problems, we will work on them. And here we will work on SMC 2019 here, and also we will work on some problems of SMC 2018. Okay, so we will work on important ideas that are same in SMC. And if you want to prepare for BMO, for SMC, want to learn important ideas, 40, 50 important ideas and formulas that you should memorize in geometry, algebra, combinatorics, and number theory that are useful in SMC, BMO1, BMO2, IMO, or if you want to prepare for AMC, AME, USAMO, I release the solution of latest BMO2, USAMO, problems of IMO. If you want to learn those important ideas and prepare yourself and find background ideas, want to solve more homeworks, want to find important points, feel free to send message to my WhatsApp number in the description comments. Okay, let's start. Problem 24, the numbers x, y, p, and q are all integers, x and y are variables, and p and q are constant and positive. The four integers are related by the equation xy equals px plus qy when y takes its maximum possible value, which expression is equal to y minus x. Okay, for solving this problem, xy, it says x and y are variables, p and q are constant positive numbers. So xy equals px plus qy. For this part, we take all things to left side, xy minus px minus qy equals 0, because they are integers. All integers, we can factorize, and how xy, and we call this factorizing Simon's favorite factoring trick. So idea 1 is SFFT. We have also one idea that we call the general form of SFFT, Simon's favorite factoring trick. Okay, I will tell you SFFT if you want to know idea 2. Feel free to send message to my WhatsApp number in the description and comments. Okay. So I want to create negative px, negative p. I want to create negative qy, negative q. Then we have minus q times minus p, pq. So it will be pq. And here it says y wants to be the maximum possible value. So the maximum, the product is PQ, P is constant. So y minus P, when y is maximum, y minus P is also maximum because P is constant. So when the product is PQ, the maximum case is PQ, the maximum case is 1. So here we can conclude x minus q is 1, y minus P is PQ. So if we add q to both sides, x is q plus 1, and y is, if we add p to both sides, pq plus p. Then the problem says y minus x is what? Y minus x is pq plus p. It is y minus q minus 1. And as you can see, the answer, the choices are something times something. So we should factorize. We write p, we write q. So we have pq now. I want to create plus p, so I place plus 1 here, plus p, minus q minus 1, minus q, minus 1 times plus 1 minus 1. So we've created all times. P minus 1, Q plus 1 is this one. Okay, we can solve this homework 1 from British Mathematical Olympiad round 2. That n is positive integer. We have 2005. X and y, which x and y are positive integers such that 1 over x plus 1 over y equals 1 over n. And then it says prove that n is a perfect square. So Try to solve this homework 1 with these two ideas. Okay, so let's solve other problems from other years and consider another ideas. This is SMC 2021. Let's try first. We have some problems here. Let's try problem 23. It says let x be a real number. What is the minimum value of this? If you want to find minimum value of this, as you can see, we have x squared plus 3 in both terms, but minus 4x plus 4x. So I3, we should know an important identity, a minus b, a plus b equals a squared minus b squared. We have also another identity, a to the n minus b to the n, general form. It is a minus b. Try to find second term on your own first, pause the video. It is a minus n and a n minus 1, a n minus 2b, a n minus 3b squared, 2b to the n minus 1 that we need here for n2. I5, we have also, if n is odd, we have another identity which is an plus bn equals something. Try to find it on your own. Factorize I6 and it's even. You can find an minus bn, a plus b times something. And also we have another identity that was useful in SMT Stanford Math Tournament 2023, last SMT. It was a cubed minus b cubed minus plus c cubed minus 3abc. You should know how to factorize. And some other important identities. Okay, if you want to learn them, as I said before, feel free. Send message my WhatsApp number in the description and comments. Now let's focus on this part. X squared minus 4x plus 3 times x squared plus 4x plus 3. And we want to find minimum value of this. Okay, so we can rewrite it as x squared plus 3 minus 4x, x squared plus 3 plus 4x. So it will be x squared plus 3 whole squared minus 16x squared. It will be x to the 4 plus 6x squared plus 9 minus 16x squared. So we want to find minimum of this. And it says, what about x? X is a real number, okay? For these types of problem, we should try to write, for example, some squares plus, for example, 1/2. Then you say, okay, there are at least 0, 1/2. And you should see, for example, can these perfect square be equal to 0? If they can, about all of them, then you say, okay, minimum is half. Now here, pause the video and try to solve it this way. So let's write idea 8, write as sum of squares. So much important, this idea. It is x to the 4 minus 10x squared plus 9. Now we can write as x squared minus 5. Then we create x to the 4 minus 10x squared plus 25. So we write minus 25 and here we have plus 9. So it will be x squared minus 5 squared minus 16. So we guess that because it is at least 0. Minimum is negative 16. We have in the choice negative 16, but we should see is it possible or not. X squared minus 5 should be 0. For example, if here we had x squared plus 5, it was not possible because x is real number, plus x squared plus 5 cannot be 0. But here, x squared is 5 and for x plus minus root 5, we reach negative 16 and our answer is negative 16. Okay, let me tell you a homework for you. We had one homework 2 is I told you write a sum of squares, try to prove a squared plus b squared plus c squared minus ab minus ac minus bc is greater than or equal to 0. A, B, C are real numbers. Are real numbers? Let's write real numbers, both negative and positive. So try to write it as sum of squares, okay? To prove. It was homework 2. Okay, now let's try problem 24. And I tell you one important idea to solve these types of problems. Okay, it says Saba, Ryan, and Darren are cooperating to complete a task. They each work at a constant rate independent of whoever else is working on the task. When all three work together, it takes 5 minutes to complete the task. When Saba is working with Darren, the task takes 7 minutes. Okay, so let's do something. Here, I8, idea 9. When you see these types of problem, maybe here we have 3, maybe we have 4 workers, 5 workers. I will tell you a way to solve all these types of problems. Okay, the idea is what? You should consider, for example, you say, okay, Saba, here because we work in minutes, suppose, for example, per minute, Saba works, for example, some percent of the work. Okay, you can consider, for example, the work is A. Without loss of generality, you can consider the work is 1. So suppose Saba works, for example, in each minute, per minute, 1 over S of the work. Okay, so in S minutes, she can finish the work. Okay, and then Ryan, 1 over R, and Darren, 1 over D. Okay, so let's read the first part. When all three work together, it takes 5 minutes to complete the work. So in each minute, they do what? 1 over S plus 1 over R plus 1 over D. So in 5 minutes, they can finish the work. So times 5 should be 1 because we've considered the work is 1. If you don't consider the work is 1, you can consider just A and then you will cancel A from both sides. Okay, if you had question, feel free to send message to my WhatsApp number in the description and comments. Okay, so Saba and Darren, the task 7 minutes. So Saba, Darren, 1 over S plus 1 over D, 7 minutes equals 1. When Ryan is working with Darren, 1 over R plus 1 over D, 15 minutes equals 1. Then it says what? How many minutes does it take for Darren to complete the task on his own? 1 over D times how many minutes? M equals 1. So we should find D. Okay? We have 3 equations, 3 variables, so we can simplify to solve the problem. So let's write. From first one, 1 over S plus 1 over R plus 1 over D equals 1 over 5. If we divide both sides by 5. For second one, we should divide by what? By 7. So 1 over S plus 1 over D equals 1 over 7. And last one, 1 over R plus 1 over D is 1 over 15. Here we have 3 equations, 3 variables. Our variables are what? 1 over S, 1 over R, 1 over D, or S R D. And we have 3 equations. One way is to use replacement. 1 over S in terms of 1 over D, then 1 over R in terms of 1 over D, and so on. But because they are special equations, good equations, we can solve also with other way. Because we want to find only 1 over D, we can add these two equations and then subtract this from our summation. Now, let's add. It will be 1 over S plus 1 over R plus 1 over D plus 1 over D, or 2 over D equals 1 over 7 plus 1 over 15, which is what? If you use common denominator, 105, 15 plus 7, 22. Okay. Now we subtract this equation and this equation. Okay. So 1 over S, 1 over R, 1 over D will be cancelled. 1 over D will be left. So 1 over D equals 22 over 105 minus 1 over 5. Okay. So it will be 105, 22 minus 5 times 21. Okay, it is 1 over 105. So M times 1 over 105 is 1. So M is what? M over 105 is 1. So M is 105. Okay, so the answer is E. Now, let me tell you, for example, we can call this idea what? We consider the per minute is what? Okay, or sometimes, for example, per hour. We want to find, for example, unit work. Okay, this idea is so much useful. In these types of problem, we can call it idea 9. Okay, this SMC 2020, problem 25, a regular m-gon, a regular n-gon, regular p-gon share a vertex, and pairwise share edges, as shown in the diagram. Okay, the vertex is this, and pairwise share an edge, it is this one, this one, this one. Okay. Now it says what is the largest possible value of p. Okay. Okay, I can tell you idea 10, which is unobvious, but I want to generalize it. If we have a regular n-gon, sum of the angles is 180 times n minus 2, because you can divide it to n minus 2 triangles. You can prove it by induction. Each angle is what is that number, because it is regular n-gon. You can divide it by n, 180 times n minus 2 over n. The number of diagonals equals n times n minus 3 over 2, because each vertex is connected to n minus 3 other vertices. Then you calculate each diagonal twice, and it will be this. Now, for example, I11 is important properties of regular hexagon. Area, find all diameters, some important points. Idea 12, properties of regular octagon. Okay, if you want to learn these important ideas, as I said before, feel free to send message on our WhatsApp number in the description comments. Okay, let's focus on this 25. Okay, here we have M and P. So the angle here is what? By this formula, 180 times n minus 2 over n for regular n-gon. It is m-gon, so 180 m minus times m minus 2 over m. This one is what? 180 times n minus 2 over n. And this one is what? 180 times p minus 2 over. And we know sum of them is 360 degrees. So let's write 180 times n minus 2 over n plus 180 times n minus 2 over n plus 180 times p minus 2 over p equals what? Sum of them 360 degrees. Okay. Now we can divide both sides by what? We can divide both sides by 180. It will be 2. So here, we can write this as m over m minus 2 over m. Or m over m, we can write it as 1. 1 minus 2 over m. Next one, n over n is 1 minus 2 over n. Next one, p over p is 1 minus 2 over p equals 2. You can cancel. You can subtract 2 from both sides. And you can cancel 1 here and take these 3 fractions to right side. 2 over m plus 2 over n plus 2 over p is 1. So we can also divide both sides by 2 and switch left hand side and right hand side. So 1 over m plus 1 over n plus 1 over p equals what? Equals 1 over 2. Now, the problem wants what? The problem says, what is the largest possible value of p? Okay, we know m and p are positive integers. Let's focus on p, because the problem only wants to find largest possible value of p. So 1 over p is 1 over 2 minus 1 over m minus 1 over n. So when we want to maximize p, so we should find minimum of this. Okay, minimum of these fractions. Let's use common denominator. 2mn equals mn minus 2n minus 2m. Okay, so we should find minimum of this. Or we can do something else. Because we don't need 1/2. 1/2 is a constant. So when we want to find minimum of 1, maximum of p, minimum of 1 over p, so minimum of this part right hand side. 1/2 is constant, so this part minimum, but because we have negative, if we consider 1 over n plus 1 over n, we should find maximum of this, okay? And also it should satisfy this part. And so we should find maximum of this, so it is m plus n over mn, maximum of this. But also, we should pay attention that if we calculate p, it will be what? Let's write 1 over p is 2mn and mn minus 2n minus 2m. So p is what? P is 2mn over mn minus 2n minus 2m. Also, it should be integer, okay? And p, because it's a regular polygon, it should be positive integer greater than equal 3. Okay, so we found this and we want to find, for this fraction, we can say what? We want to find largest possible value of this fraction. Okay, for this part, because we know p is integer, let's find all possible values of this fraction that are integers. So here, we should use what idea? I12, I13. We should be able to work with divisibilities, okay? Ideas in divisibilities. Here we know mn, the denominator divides 2mn. And I want to get rid of 2mn, so I say mn minus 2n minus 2m divides 2 times itself. Look, a divides 2a. 2a obviously is multiple of a. So it's 2mn minus 4n minus 4m. So if we subtract this minus this, so mn minus 2n minus 2m divides 4n plus 4m. Now, we know that if this part is not, this part shouldn't be 0, okay? Because it is in the denominator. At the end, we should check. Denominator shouldn't be 0. And we know that if a divides b and b is not 0, then we can conclude absolute value of a is less than or equal absolute value of b. So here we can conclude absolute value of mn minus 2n minus 2m is less than or equal absolute value of 4n plus 4m. Because n and m are positive integer, because regular n gone, m gone in the problem, here it is 4n plus 4m. But here, we should check two cases. First case, if it is negative, mn minus 2n minus 2m, if it is less than 0. So we can conclude it is less than or equal negative 1, okay? Then we should consider negative of this. So in this case, we can say m minus, we can use again SFFT that we use in other years. n minus 2, m minus 2, n minus 2, then we have mn minus 2m minus 2n plus 4. It is at most 3, okay? 4 minus 1. Now, if we consider cases, mn, we know there are at least 3, so if we have 3, 3, it will be okay. If we have 3, 4 also. And the problem is symmetric with respect to m and n, and we want to find largest possible value of p. So if we consider 3, 4, we don't need to consider 4, 3. The next case is 4, 4, but 4, 4 doesn't satisfy because it will be 2 times 2, 4. So we should only check these two cases. Okay, m3 and 3. So satisfy these. Now if we consider, if we check p, p is 2mn. Let me write 2mn over mn minus 2m minus 2n. Okay. So for this case, p is 2 times 3 times 3, 18 over 9 minus 6 minus 6, which is negative. And one important thing, if mn minus 2n minus 2m will be negative, this one positive, positive over negative, negative. So we can reject both cases here. So we have case 2. mn minus 2n minus 2m, and because it is denominator, it is at least 1, we know. Because p is positive, it cannot be 0 because it is in the denominator. So let's write this. mn minus 2n minus 2m is less than or equal 4m minus 4, 4n plus 4m. So we can write mn minus 6n minus 6m is less than or equal 0. Okay? So we can use factorization. Again, SFFT, less than or equal what? 36. Okay? So let's consider the cases. We know what mn, for example, if mn equals, and we know something. This part is at least 1, let's also focus on that. n minus 2, it is at least 4 plus 1, 5, okay? We have also this condition. So 3 doesn't work here, okay? Okay, let's consider this one property 1, property 2, and let's check can we find other properties, because here we should check lots of cases. 12 up to 12 satisfies, so as you can see, we should check 12, 11, also for example 13, 5, something like this. So as you can see, also let's consider this one, that P is at least 3. So 2mn, let's erase this part, let's try to consider all things that you think may be useful. Mn minus 2m minus 2n. This one is at least 3. So 2mn is at least 3mn minus 6m minus 6n. Again, here we can say mn minus 6m minus 6n is less than or equal 0, 3mn. So again, we can say what? m minus 6. n minus 6, but here less than or equal 36. Okay, again here we've reached same result as 2. Okay, when we reach this, now try to check some examples. Okay, I13, I14, also in function we should check. Consider some examples. And let me tell you something. Some examples. We want to find maximum P. When we increase, for example, M, then the angle will be increased. Why? Because it is 180 minus 360 over M. Okay, so when we increase M, the angle will be increased because 180 M over M is 1, 180 minus 2 times this over M. So if you want to find maximum P, we try to decrease M and N intuitively, if you want to think. Intuitively, we should decrease M and N. So let's find smallest cases that are possible. So here, because we have this condition, M should be both of them are at least 3. And we can consider without loss of generality, suppose M is at least N. So N is 3, the minimum case. If N is 3, M is at least what? It is 1, it should be at least 5, so M is at least 7. Okay. For example, if N is 4, it's 2. This one 2 times what is at least 5? 2 times 3. So M should be at least 5. Okay, these are the minimum cases. And so, for example, for 3, if 3, 7 works, we shouldn't check 3, 8 because it will be the best. Now for P. We know the formula of P was what? 2mn over mn minus 2m minus. So here, P will be what? Let's calculate. Let's move it here. 2mn is what? 2 times 3 times 7 over mn is what? Is 21 minus 2m minus 2n minus 6 minus 14. So it will be 42. Okay, so we found one good case, 42. Let's check, for example, 4, 5. It is 2 times 4 times 5 over 20 minus 8 minus 10. 20 minus 18 is 2, 2 will be cancelled, it's 20. So 42 is so much better. Now, if the minimum one, for example, is 5. If the minimum one be 5, so M should be greater than equal 5, okay? Because 3, 7 is best, let's check up to 7. So 5, we know it is 3. 5, 4, we've considered, when we considered 5, 4, if we consider any number greater than 4, we found better than that. So we shouldn't consider this because 5, 4 also, P was smaller. Now let's consider 6. If it is 6, 6, 3, let's check. 6, for example, 4, let's check. Let's check these numbers to see the minimum number that works with 6. 2 times 6 times 3, 3 times 6, 18, minus 8, 2 times 6, 12, minus 2 times 3, 6. This one, let's check 6 minus 3. It doesn't satisfy first condition. Okay. So let's start from 6, 4 first. Okay. 6, 3 doesn't satisfy equation 1 because it will be 4 times 1. 6, 4. It will be 2 times 6 times 4 over 6 times 4, 24, minus 12, minus 8. So it is 20, 24 minus 20 is 4. 4, 4 will be cancelled, it's 12. So it's bad. If you check 6, 5, it will be worse because if we said if we increase m and n, then p will be decreased because of the angles we've proved. And for after 6, if you use 7, because we know m is greater than or equal n, the answer will be worse than this. So the best answer is 42 here. Okay, so we've considered from different aspects this problem 42, 14 ideas up to this part. So now let's focus on some problems of other year. Here also we have function problem. Let's try this function problem. Problem 23. It says a function f satisfies y cubed f of x equals x cubed f of y and f of 3 is not 0. What's the value of this? Okay, so when you see a function problem, there are lots of ideas. I-15 is to check small cases. It's similar to idea 14. Check special cases. Special cases is different as a small cases. Why? For example, here you say, okay, x is 1, something like this. Here you say x equals y, x equals negative y, something like this. I-17, try to get rid of complicated term. It was useful in BMO round 2. I will tell you the problem. And without this also you could solve. And USUMO, for example, 20 US SUMO or USAJMO. I don't remember, I will tell you. 2023, last. Okay, this one a problem of, let me see. It will be homework what? Okay, homework 3. I refined it if you want to know exactly it was which problem. PMO 2, I think it was 2021 or 2020 or 2022, maybe 2022, I think. But I will check it if you want to know exactly the problem was what. Feel free to send message my WhatsApp number in the description and comments. It was USAMO or USAJMO, but the year was 2023. Function problem. I released the solution of this in my channel. So here on another idea we have also telescoping rule. Again, one problem of homework 5, one problem of AMC 10A. 2022 could be solved with this one. Homework 6, a problem of BMO 1, I know that you can solve. It was function problem. It is BMO 1. A function problem. In that problem, we should use telescoping rule. Sometimes you should use general form of telescoping rule for these types of problem. General form of telescoping rule. And you can try a homework. Homework 7, one problem of BMO1, last BMO1. Last BMO1. One problem could be solved with this idea. I release a solution. If you want to know exactly the problem was what, as I said, you can send message to my WhatsApp number. Okay. We have also other ideas in functions. For example, one important idea, I-20. Check to see, is it 1-to-1? 1-to-1 means f of x equals f of y, or injective function, x equals y. One problem we can solve it as homework. Also in USUMO we have these types of problem. In IMO we have these types of problem. One problem from PMO, Philippine Mathematical Olympiad, national level, last PMO. national level, which is for 2023. One problem is function problem. You can solve it by using also one-to-one. Okay, let's try this problem. Okay, let's work on this here. A function f satisfies this. So, one good thing is that you can, for example, replace x with 1, okay? We don't check x and y equals 1. We check x1 if you see, okay, is still complicated. We can consider both of them 1. So x is 1, f of y equals y cubed f of 1, okay? So here we can consider f of 1 equals c, a constant. So it is y cubed c, and c is not 0. Why? Because f of 3 is not 0. F of 3 by this formula is 27c. The problem says f of 3 is not 0, so c is not 0. And f of 20 is what is 20 cubed c minus 2 cubed c over 3 cubed c. We can cancel c from both numerator and denominator. It's 20 cubed minus 20 cubed. So we can say it is what? It is 8,000 minus 8 over 27. Or we can factorize right side. That's okay. Let's calculate this. It is 2,997,992 over 27. Let's divide first both numerator and denominator by 9. It's 872, 872, 8 over 3. And it is 228, 9, 18, 6. It is 296. Let's try problem 24 of SMC 2019. The numbers x, y, and z are given by x equals square root of 12 minus 3 root 7 minus square root of 12 plus 3 root 7, y and z. They have also this form. What's the value of x, y, z? Okay. For these types of problem, it will be idea 21, I think. Let's check here. I told you up to idea 20. Idea 21. We had also this in SMC 2022 that I released the solution. We have two approaches. Raised to the power of 2. One approach is try to use changing variable and consider this one as a. So if we solve here the problem, x is this. So x squared is what? We use the identity that a minus b whole squared is a squared minus 2ab, or a squared plus b squared minus 2ab. So the first one squared is 12 minus 3 root 7. The next one plus 12 plus 3 root 7. And the next one minus 2 times square root of a minus b, a plus b. A minus b times a plus b is a squared minus b squared. Okay. 12 times 12 is 144 minus 3 times 3, 9 times 7, 63. Okay, so if you write this one will be cancelled. 12 plus 12, 24 minus 2 times square root of 81. Okay, so 24 minus 2 times 9 is 18. So it is what? It is 6. So we can conclude x is what? Is plus minus root 6. But how can we understand that it is plus root 6 or minus root 6? Can you tell me? Pause the video and try on your own. Look, x is this minus this. Which one is greater? Obviously this one. So it is negative. So we can conclude x is negative root 6. By the same way, we want to calculate y squared. If you do the same thing, it is 7 minus 4 root 3 plus 7 plus 4 root 3 minus 2 times square root of 49 minus 48. This one will be cancelled. It is 14 minus 2, which is 12. Again, y is plus minus root 12. Which one is greater? This one. So it is negative root 12. Now let's calculate last one, z. Z squared or z squared is 2 plus root 3. The first one squared plus 2 minus root 3 minus 2 times square root of 4 minus 3. Root 3, negative root 3 will be cancelled. 4 minus 2, which is 2. So z is plus minus root 2. But as you can see, this one is greater than this one, so z is positive. So z is plus root 2. Now the problem says xyz is what? Or xyz. xyz is negative root 6, negative root 12 times root 2. Which will be root 6, negative negative will be positive, root 6 times root 6 is 6, so root 2 is 2, 6 times 2 is 12. So the answer, the correct choice is E. So we've used this idea raised to the power of 2. Okay, let's solve a problem from SMC 2018. For particular real numbers a and b, the function f is defined by this and is such that f of x is this. Which of the following formulas defines the function g such that for all values of x, g of f of x is x? Okay, let's try. You have these types of problem also in CSAT for Cambridge and other exams. You have f of x ax plus b, so let's calculate f of x. So problems that we have, let's consider is 22. You have fn of x. You can replace, you can calculate like this. You say, okay, f of x is what is ax plus b. Now f of this is what is a times ax plus b if we use this function, okay? Now it will be what? It will be a squared x plus ab plus b, okay? Now we want to calculate f of x, okay? 1, 2, 3. So we use f of x. It is f of a squared x plus ab plus b. So it will be what? It is a times a squared x plus ab plus b plus b. So it will be what? It will be a cubed x plus a squared b plus ab plus b. Now we found f cubed of x, f of x. Now we want to find g of f of x. It says what? Which of the following formulas define the function g such that it is one important idea you can use if you couldn't solve is check the choices. In this problem you can solve with checking the choices, but in some problem it will be so much easier. Okay? And we know it is 27x plus minus 52, so we can find a and b. When this is so much important in polynomials, let me write it as 24. Each polynomial has, for example, if p of x is a polynomial, a n x n to a1x plus a0, an is not 0, so the degree of p of x is n. So p of x, you can write it p of x as an x minus r1 to x minus r, and maybe some of ri's are equal, which ri are in complex numbers. So it has n complex roots and at most n real roots, because some of them are not real. They are complex numbers, not real complex numbers. At most n real roots. And the other thing that you should check, so if you have more than n roots, then all coefficients 0. And now, if you have, for example, p of x equals q of x. For example, p of x, the degree is n, anx n to a0, and amxm to, bm, the coefficients b0. If they are equal for more than maximum of their degree, then we conclude they are exactly same. M equals n and an equals, because m and n are equal, an equals bn to a0 equals b0. Like this one, it says they are equal for more than the degree. The degree is 1. So we can consider the corresponding coefficients are equals. A cubed is, a and b are real numbers. A cubed is 27, so the only case for a is 3. If we replace here, 9b plus 3b plus b equals negative 52. 9, 3, 12, 13. 13b equals negative 52. So b is negative 52 over 3, which is negative 4. Okay. A3, B4. Now, we can conclude that f of x is what? F of x is ax plus b. F of x is 3x minus 4. Now we want to see g of x is x, g of f of x. So g of 3x minus 4 is x. Again, one idea, let's call this idea 25. When you see something like this, you want to find g of, for example, something, try to use changing variables. So w is this. So 3x minus 4 is w. So we want to find x in terms of w. 3x equals w plus 4. So x is w plus 4 over 3. So g of w is x, which is w plus 4 over 3. So we can change variable. G of x is x plus 4 over 3. Which of them is x plus 4 over 3? X plus 4 over 3. Choice B. Okay? Okay, so we've solved these problems. We have a lot of homeworks, 25 ideas. If you want to learn other important ideas, and we have 50 important formulas in geometry, algebra, combinatorics, and number theory. If you want to learn them and find background ideas of SMC, then BMO1, BMO2. As I said before, feel free to send message. My WhatsApp number in the description and comments. Okay.